So, in this lesson, this is operations in scientific notation. We're going to be adding, subtracting, multiplying, and dividing. There are really specific rules of how you should be adding, subtracting, multiplying, and dividing numbers with scientific notation. This is PSSA review content. But to be honest with you, I'm going to list the rules of how you should be doing this if you were to be specifically learning this and memorizing this for a test. However, you are going to be allowed to use a calculator. So I am going to give you the rules. However, I am going to show you the way that Ms. Fariska and I do this as well. So the way that we do this is a little bit different that you might see this in the notes. And it is a faster way of doing this. And again, this is PSSA related content. So we don't like to focus 100% on this. But again, it's something that you will see whenever you guys take the PSSAs. So we want you to be a little bit aware of it. So, when you're adding and subtracting numbers in scientific notation, the importance is that you have the same power on 10. Okay, and if you would have different powers on 10, if you look through these notes, they would be showing you how you would be able to move a decimal point around so that you would get a same power on 10. However, since we actually know how to write numbers in scientific notation, I'm going to show you how to do it that way instead. And then we're going to actually just use our calculator to simply use everything by putting it in standard form first and then converting our final answer into scientific notation in the end. So if you take a look right now at the first question, we have 8.2 times 10 to the second power. And I'm going to only show you one problem from each, and then you can go ahead and check your answers to make sure that you're doing this correctly for each section, just so you know what the game plan is for this. All right, so if you look, we have 8.2 times 10 to the second power. So if we have 8.2 times 10 to the second, we know we're going to be moving our decimal point 2 places. So this is really 820. And we're going to be adding to that 3.41 times 10 to the negative 1. So we're dealing with a tiny decimal, so we're going to be moving our decimal point to the left. So really this is 0.341. So you are allowed to use your calculator when you take the PSSAs. So we're going to add 820 plus 3.41. And we get 820.341. Now, final thing that you would need to do is put this into scientific notation. So remember, to write something in scientific notation, you need to make sure you're moving your decimal point so that it's in between the first two numbers, so that it would be a number in between 1 and 10, so greater than 1 but less than 10. And you do, in fact, need to include all of these numbers, because if we would multiply this out, we want to make sure that we actually get the same number back. So I'm moving this decimal point 2 places. So this would be 8.20341 times 10 to the second power. All right, now we want to make sure that we get the same result back. So let's see if we did this correctly. And again, here's the work behind it. So 8.20341 times 10 to the second power. All right, so here I'm going to try it on my calculator. And you can see that I got the same result back. So again, I'm using my calculator, but again, I also am getting the same result by converting things back into between scientific notation and standard form. Okay, I'm going to save question number 2 for you to complete in a moment, but let's try out this next problem. Problem number 3 is subtraction. So let's do this process where we first move everything into standard form, and then we'll subtract the two numbers using our calculator. So we have 7.8 times 10 to the negative fifth. So I'm going to move this 1, 2, 3, 4, 5 places. 1, 2, 3, 4. So I really have 0.000078 minus, and then I have 4.5 times 10 to the negative fifth. So 1, 2, 3, 4, 5. So 1, 2, 3, 4. So what I'm going to do with my calculator now is I'm going to take these two numbers that are in standard form, so 0.000078 minus 0.000045, and I'm going to subtract these two numbers. And the result I get is, I'm going to write this down on my Jamboard. So point, and then I have 1, 2, 3, 4 decimal or 4 zeros, and 3, 3. So my next move is I need to put that into scientific notation. So I need to move my decimal point in between the two threes so that I get a factor that is between 1 and 10. So 3.3 times 10. Now, since I'm dealing with a tiny decimal, I want to make sure that my exponent on 10 is a negative number. So 1, 2, 3, 4, 5. So my final answer would be 3.3 times 10 to the negative fifth. And again, I'm going to check this right now. So 3.3 times 10 to the negative fifth. And you can see I'm getting the same result. So again, I want to leave my answer in scientific notation, but you can see that I'm converting in between with standard form to help me to get my result. So I want you to try out question 2 and question 4 right now to see if you can do this part on your own. All right, guys, so let's see if you got those answers right. So if you were to actually work out and see what each one of these numbers would be in standard form, 2.1 times 10 to the negative 4 would be 1, 2, 3, 4. So 1, 2, 3 zeros, and then 2, 1 plus, and then we would have 9.74, and then 1, 2, 3, 4. So 1, 2, 3 zeros with 974. When you would add those numbers up, you would get 0.001184. And then when you would convert that back to scientific notation, that would be 1.184 times 10 to the negative third. Very similar process over here on problem number 4, except we're dealing with larger numbers. So 4.7 times 10 to the fifth, we're going to the right. 1, 2, 3, 4, 5. So 1, 2, 3, 4 zeros I have to fill in there. So that would be 470,000 minus, and then we have 7.2 times 10 to the third. So that would be 1, 2, 3 places I'd be moving. So that'd be subtracted by 7,200. So when I subtract those two numbers, I would get 462,800. And then if I convert that back into scientific notation, that would be 4.628 times 10 to the fifth power. And again, this process is going to be similar no matter what operation that we do. So again, if you want to read through how the correct process would be if you didn't have a calculator and how you would have to make sure you use those rules of exponents, where you would divide the factors in front, keep your power of 10, and then subtract your exponents to get the correct answer, you can certainly do that with whenever you're dividing. And with multiplication, you'd be keeping your base and adding your exponents. So you can certainly do that. But if you want one process that works for every single time, you would just go with the same process that I'm just mentioning by converting the numbers into standard form. And then you would just be converting everything back into scientific notation at the end. So for example, again, for question number 1, if I had 2.5 times 10 to the 8th, I'm writing down my 2.5 and sliding at 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to fill in with all those zeros. Okay, so there's my number. And then I'm going to multiply that by 2 times 10 to the third. So again, I'm going to be sliding that over 1, 2, 3 places. You would be multiplying these two numbers together and then converting that into scientific notation. Now, you technically could just use these numbers and then just multiply that out. So here we go. I'm going to take, it's at 2, 5, and then I have 1, 2, 3, 4, 5, 6, 7 zeros behind that. 2, 3, 4, 5, 6, 7 zeros times 2,000. It actually gave me my answer right there in scientific notation. So we lucked out. Our answer is going to be 5 times 10 to the 11th power, and we're done. Okay? And again, we're going to allow you to use your calculators on this. The PSSAs will allow you to use your calculators on this. So again, it's a lot of different things you can do, but a lot of this is punching buttons in your calculator. Okay? So here's question number 1 with the answer of 5 times 10 to the 11th power. Okay? I'm going to show you number 4, and then I'm going to have you guys try out numbers 2, 3, 5, and 6 on your own. Okay, for question number 4, you would do 1.5 times 10 to the negative third. So 1.5, I'm going to slide that over 1, 2, 3 places. So I'd have 0.0015, and I'm going to divide that by 7.5 times 10 to the second. Now 10 to the second is a positive exponent, so I'd be sliding it 2 places to the right. So that's really by 750. So I would have, again, on my calculator, 0.0015 divided by 750. And here's my answer. And again, I'm going to write this on the Jamboard for you guys as well. So that's 0.00002. I think there's 1, 2, 3, 4, 5 zeros and then a 2. Okay, and then my last step is I want to put that in scientific notation. So I would want to make sure and you have that factor that's between 1 and 10. So that means you have to slide the decimal point behind the 2. So it would be 2 times 10 to the negative, let's see, 1, 2, 3, 4, 5, 6. So there's your answer, 2 times 10 to the negative 6. So again, I'm going to pause the video and I want you to do the same. And I want you guys to try out 2, 3, 5, and 6 and make sure you can use that calculator to help you to get those answers correct. All right, guys, so let's see if you got those answers right. So for question number 2, no matter what process you're using, it's 4.8 times 10 to the negative 4th. For question number 3, it's 2 times 10 to the 12th. For question number 5, it's 2.1 times 10 to the 8th. And for question number 6, it's 1.325 times 10 to the 11th power. All right, so there are some application problems with these as well. You do need to determine what operation you're going to be using in scientific notation to help you. So in this one, it says how many times greater is the diameter of the sun, not the sum, so the sun, than the diameter of the earth. And you can see the diameter is in standard form of the sun and the diameter of the earth is in scientific notation. So if we're trying to figure out how many times greater it is of the sun than the earth, we're probably going to be using, I would think, some kind of maybe multiplication or division to try and figure that out. So if we start by looking at the diameter of the sun, it's 1,400,000 kilometers. Okay, and we know it's bigger than the diameter of the earth. So we're trying to figure out maybe how many times greater that is. So I'm thinking that we're going to need to divide these two numbers together. Okay, so what we can do right now is we already have the sun's diameter in standard form. Why don't we take that 1.28 times 10 to the 4th and get that into standard form too, so that we could divide those two numbers together. So that 1.28 times 10 to the 4th, I'm going to slide my decimal point 1, 2, 3, 4 places. Tack on those 2 extra zeros. So that would be 128 with 2 extra zeros. So that would be 12,800. Okay, so I'm going to take those two numbers and I'm going to divide them. So 1400, 1, 2, 3, 3 more zeros. And I'm going to divide that by 12,800. Okay, it's telling me the answer is 109.375. So it's 109.375 times greater than the diameter of the Earth. All right, I'm going to write that answer in scientific notation. So I'm going to slide my decimal point 1, 2 places to get that factor in between to be greater than 1 but less than 10. So 1.09375 times 10. Now since I slid it 2 places to the left, that's going to be to the negative 2. And I'm going to just check to make sure that I did that correctly. Okay, you can see I did not, so it's a nice way to double check. So instead of making a negative 2, I should have made that into a positive 2, right? So 1.09375 times 10 to the positive 2 would have given me that same result back that I wanted, right? Yep, so I have the 109.375. Okay, so again, calculators are a wonderful thing. You can double check to make sure you got those answers correct. So if I slid it 2 places to the left, I have a positive exponent. So I got that positive 2 there. So 1.09375 times 10 to the second power, not negative 2. Okay, and then there's your answer. All right, so again, this problem here, I want you to try it out and pause your video to see if you got it correct. Okay, how many times greater is the thickness of a dime than the thickness of a dollar bill? And I would like you to leave your final answer in scientific notation. And I want you to check your answer to make sure you don't make a silly mistake like I did. All right, so to get you started on this one, you want to take the dime and you want to divide that by the dollar bill. So 0.135 divided by, I converted that to standard form, so 0.010922. All right, when I divided that, it gave me 12.36 and then a whole bunch of decimals behind it, okay? So if I were to convert that into scientific notation, it would be 1.23 and then it's a whole bunch of decimals behind it, all right? I think just for our sake, just because I'm getting a big decimal, maybe not to put this in scientific notation. So I'm just gonna say it's about 12 times greater. I'm just going to look at the number that's in front and I'm just going to copy that part down because I'm getting a big decimal on this one. So I'm going to use these approximately equal to symbol and it's going to be 12 point, let's say about 36. Okay, so I'm estimating this one, and I'm not going to put it in scientific notation this time. I know I originally said that, but just because it's really big this time and we'd be cutting off a lot of digits on this one. So we're going to say it's about 12 times greater on this one. So we're to say that the dime is about 12 times greater in terms of thickness than the dollar bill. Okay, so in looking back through this lesson, you can see that we've learned a bunch of different things. We've learned about adding, subtracting, multiplying, and dividing in terms of scientific notation, but it's pretty much been the same process. You take no matter what numbers you have and you convert them into standard form first. You perform the operation just with your calculator, and then you convert that answer back into scientific notation. There is one last problem. If you look here, it says to find the perimeter of the rectangle, and then it gives you the area. So we're going to try that one out last, and then Let's see if you got that one right. To make sure you do this one correctly, it says to find the perimeter of the rectangle. Remember, to find a perimeter, you're adding up all the sides. Well, perimeter of a rectangle would be you're taking 2 times the length plus 2 times the width. We only know one of the dimensions. One of the dimensions right now would be 9.2 times 10 to the 7th power. So that means we have one of those. We know we can maybe get the other one from the area. Okay, so here's our idea. We know area is length times width. Okay, if I know that the area whole thing is 5.612 times 10 to the 14th, and I have one of the dimensions. Let's say maybe I know the length. We'll say that's 9.2 times 10 to the 7th. I can get the width to help me to get my perimeter, and I can do that by dividing by my length. So right now, what I want you to do, and this is like a baby step to get your perimeter, let's first try to get our width. So right now, I want you guys to do 5.612 times 10 to the 14th, and we're going to divide that by our length, which is 9.2 times 10 to the 7th. Let's get our width right now first. So whenever I figured out my width and I divided those two numbers just using my calculator, I ended up with 6,100,000 for my width. I'm going to use that to help me to calculate my perimeter, which is what I ultimately need to find. So I'm going to take that answer of 6,100,000 and I'm going to plug that in for my width into this perimeter formula. Okay, so I'm going to do right now 2 times my width, because that's what the formula tells me to do. So 2 times 6,100,000. And then I'm also going to do 2 times my length, which in this case is 9.2 times 10 to the 7th power. I'm going to take 9.2 times 10 to the 7th and convert that. So 1, 2, 3, 4, 5, 6, 7 zeros, or maybe not 7 zeros. I have to move my decimal point 7 times. 1, 2, 3, 4, 5, 6 zeros. So I'm going to put the 9.2 there, or the 9.2 with the 6 zeros. 1, 2, 3, 4, 5, 6. Okay, so I'm going to do that on my calculator and see what that answer is. Okay, now it doesn't say to write my answer if we're not in scientific notation, but I'm going to because I see the other parts already are. So right now I'm going to do 2 times 9, 2, and then 1, 2, 3, 4, 5, 6. Okay, so that's the result when I do 2 times my length. I'm going to write that down on the Jamboard for you guys. That's 184 million. And I'll also do 2 times my width. Okay, and the result I'm getting is 1, 2, 3, 4, 5 zeros. So that would be 12,000 or 12,200,000. Okay, so then my last step is I'm going to be adding those numbers up and putting my result in scientific notation. Okay, so here's the result. The perimeter of this is really large. It's 1, 9, 6, 2, and then 1, 2, 3, 4, 5 zeros. So 196,200,000. Okay, and that's in terms of centimeters. Now we're talking a perimeter, so we're just going to leave the units just as is. I'm going to write my answer in scientific notation. So that means I'm going to put the decimal in between the 1 and the 9. So 1.962 times 10, and then 1, 2, 3, 4, 5, 6, 7, 8. I'm dealing with a large number, so it's going to be a positive exponent. So my result would be 1.962 times 10 to the 8th centimeters.